We will discuss in terms of HHO generators fitted to engines. We will discuss the different engines. Petrol machine versus diesel machine. For a lot of people, they see petrol machine is using petrol and diesel is using diesel. And it's not that simple. There is a lot of differences between the engine, that is spark ignition, and compressor ignition. And both of them will have different results with the HHO generator, and different things will affect the HHO generator. And we need to understand the function of the petrol machine versus the diesel machine. What I've shown here is the petrol machine is also called the spark ignition machine, which is a petrol that's make use of spark plugs. It's also called the auto cycle machine. I normally just called it SI, spark ignition. And I have shown here a y-axis that is increasing from 0 to a higher value, and an AFR scale on the x-axis, 0, and increasing all higher and higher in values. I also have drawn a line here that represents the optimal AFR, the optimal air-fuel ratio. Now, when we talk about a petrol machine, the optimal AFR is 14.7. What does it mean? That means if I take the air mass in gram and I divide by the petrol that was being used, I should get a 14.7, which represents 14.7 gram of air to 1 gram of petrol. Now, if you look on this side here, this zone here, actually shows you the rich zone because it's lower than the AFR. That's the rich zone. It also shows you the lean zone, which is on the right hand side of your optimal AFR. In other words, fuel mixture is lean at this side, your fuel mixture is rich that side, and we got a kilowatt curve running that represent the different kilowatts against AFR. It's the same. We also got a blue curve that is showing the best fuel economy at that specific AFR. What we will immediately notice that the AFR of about 12.4, in other words 12.4 to 1, 12.4 grams of air to 1 gram of fuel, is normally the range where the maximum power is developed for a SI machine. The best fuel economy is about 15.2 to 1, which means it's 15.2 grams of air to 1 gram of fuel. So at any instance, if I take that air mass gram that has been used, if I used 2000 air mass, for example, and I've used 1000 grams divided by 2, I get a ratio of 2 to 1. So a petrol machine has got a very more precise type of management system, and it is driven by a primary loop that is a closed loop system, and the oxygen sensor, also what we call lambda and oxygen is the same thing, that your oxygen sensor is the one that controls your whole engine management system. It's about efficiency and it's about emission control. Now, if we look at this is a little bit of a closed loop system. At the moment, the machine has determined that a set point, he wants an AFR of 14.6 to 1. The ECM, your car management system, will calculate the injection pulse based on that set point and based on a lot of other sensors. So, for example, the temperature of the car, the coolant temperature, the mass of the air that went in, etc., etc., and it will determine what the width of the injection pulse must be, and it will inject that fuel into the combustion chamber. Combustion chamber will explode. It will release the gases into the exhaust after your compression and your explosion stage, and then your oxygen sensor will measure to see what happened. So after all of these calculations and after all the happenings in the combustion chamber, this sensor, for example, will measure for 15.3. It will be fed back into what we call a summing joint. This is just a basic instrumentation loop. It will then look at the one is positive, your set point. It will then look at the difference between the two. And it will say, I wanted to be at 14.6, but I ended up after all of these calculations and after the fuel was injected and exploded in the chamber and it ended up in the manifold with a true value of 15.3. So it will correct that sensor because now I got what we call an error signal. That error signal will be interpreted by the ECM. It will then change the injection pulse, bigger or smaller, and it will then recorrect it until the set point and the actual is the same. Now, it's very important to understand that on a petrol machine, a lot of people will just say, if 15.2 is the best consumption, I want a car that runs at 15.2. Now, it's not that simple. Because the problem with a fuel mixture on a petrol machine is the further you go from your optimal AFR to the right-hand side, your fuel mixture is represented as a higher AFR value. But as you move away from this, you are also increasing your combustion temperatures and what we call EGT, exhaust gas temperatures. So as you move away from here, your exhaust gas temperatures is also rising. And this is critical on a petrol machine. Because a petrol machine, you got a stroke, and in the beginning of that stroke, you're actually spraying your petrol. It atomizes. It gets mixed with the air because it's now atomized particles inside your air. It starts moving around. It's getting compressed. And you will understand that this mixture is too lean. Because of this combustion process that is now getting hotter and hotter as it gets leaner and leaner and moving away from the optimal, that mixture of air, while it's been compressing, it will ignite, what we call knocking predetonation, because it's only the spark plug that must ignite that mixture. But because the mixture is so lean that your gas temperature, because of the compression, is so hot, it will ignite the mixture, and that you don't want. Because with knocking, if knocking a gear once or twice, it's not a challenge. But if knocking is a continuous, you allow knocking to occur continuously, it will actually damage the engine, the pistons, everything will be damaged. The same with the other side, the fuel mixture is rich. If you go lower on this side, your fuel mixture becomes rich, and you got a maximum power of about 12.4. Now, you would not like to run all the time on that side, and you would not run on this side, because sometimes your vehicle is idling, then your set point is never a fixed point. That 14.6 can change. For example, if you idle your vehicle, the engine management system look at your accelerator pedal, or it look at your butterfly valve in your throttle body, and it will then say, okay, this person doesn't need power, and he will actually go into a lean zone where a little bit of fuel is injected, and for that time period it's not a problem because the engine has got no load on, it's got zero load in, it's running lean, it's fine. But you also get into stages where you need power for overtaking vehicles or to accelerate rapidly, and then you need to be in this zone here. So it all depends on the load of the engine, and it all depends what the end user wants. So that's why it's never a fix, because else it will be very, very boring to drive a petrol machine. Now, lambda 1, if we talk a lambda 1.2, we're normally in the rich side. If we talk about 0.8, we know correction. If we talk 1.2, we're in the lean side because we went up on the scale. If we talk 0.8, we know we are in the rich side. Now the narrowband oxygen sensor, we need to discuss this. I call the narrowband oxygen sensor normally the policeman. This is the policeman in terms, and what his duty is to protect your engine from abuse, that your engine never get into a situation where it's unsafe to operate. For example, it's running too lean, and you're going to burn your valves, and you're going to burn your holes in your piston. So this policeman is a sensor, oxygen sensor is a narrowband, and his function is basically to say go, no go, yes, no, bad, or not, or good. And that is his function. The function of this sensor here is the wideband sensor is more or less for control purposes. And this one here and that one there is also in relationship to each other. For example, if you remove your catalytic converter, this one here and that one there will be about the same. And then these two sensors will actually cause the engine management to actually flag a fault code. And then you've got all kinds of challenges. The moment when this and that becomes the same, it will fall back from a primary loop into what we call an open loop, and it will then be in a different situation. And what happens then is, instead of operating here certain times and certain times there, it then goes to a mapping system where it says catalytic converter has failed or it's removed, and it will actually push us more back to the reach side to ensure that you operate this vehicle in safe limit. But the problem is, the moment when it operates here on a mapping of the different loadings, different speeds, but it's an open loop system, you will see that your fuel consumption goes up. And this is what happens normally if one of these sensors fail or you remove your catalytic converter. So it's not a very good thing to remove the catalytic converter or not to replace the sensors. Normally, when a person has a huge problem with his car and he's complaining about fuel consumption, we will first look at this sensor here and that sensor there. Now, also what is important is your primary loop is lambda control, oxygen sensor. Your secondary loop is air throttle control. This allows more or less air. When you move your accelerator pedal up and down, it actually moves this butterfly inside your ducting for your air that restricts or allow more air in and out of the machine. A diesel do not have air throttle controls. But on this one here, it will first do the secondary loop, and that will go back to primary loop. An oxygen sensor will then ensure that you do not exceed the emission standards and that the petrol machine is operated in a safe way, that you don't damage the machine. Now, we need to look at the oxygen sensor. Let's look at this narrow band. The narrow band normally runs from about 14.2 to 1 up to 15.1. And what is interesting about the sensor, that if you operate at 14.2 exactly, you will have a voltage output of about 0.4 volt. If you are now running lean and you're running at 15.1, which is very close to the base consumption there, your voltage output will be about 0.8 volt. And in the middle of these two, if you're running at the optimum level, you will actually run at 0.5 volt. Around there, 4.9, 4.8, 5.1. But that is, we can calibrate that to be correctly. Now, there's a lot of factors that we have to take into account. The control system, it's very complex. If you look at this sensor here, and for example, it's a very accurate sensor. We normally do not fiddle with a zero. If we calibrate the sensor to our microprocessor, we do not touch the 0 point, but we will touch the span, in other words, the top point of the sensor. So we will calibrate 0.8 and we will leave it at 0, and we will just put the right values in to calibrate and to use. And then C++, we use what we call a mapping, and a mapping is done in microseconds. Now, we need to discuss a little bit more about what can go wrong when you put HHO generators onto the system. When you put HHO generator onto a carburetor model, there's no changes needed. The moment when you put HHO generator onto a carburetor model, you have an instantaneous saving, immediately, without question. But with the newer cars, and it all depends on the frequency responses of your machine. If you've got a modern system, these changes will appear very, very quickly in the system, and there will be a very quick reaction times. And I need to explain what can go wrong when you add HHO. Let us say that there was a certain person X, have seen HHO generators. He's read through all the articles and he decided this is the way to go, and he wants to put it onto his SI machine because he wants to save the environment from getting damaged and he wants to have fuel economy. So he's going to buy the system, he install it, and he's very happy, and he starts the machine. And this machine, at that stage when he started it without the HHO generator on, he can be operating here at 14.6. But the machine is happy because the actual is 14.6, the set point is at 14.6. This machine is in his element. His set point is at 14.6 and the actual is 14.6. Now the moment when you start your generator, HHO generator, there is a couple of things that happens. It changes your emissions. Your soot, your CO, your CO2s, everything goes down. But there's one gas where the quantity actually goes up. It's not harmful to your engine, but that's your oxygen. If you run an oxygen analyzer, a gas analyzer in your machine, you will see you have an increase of about 10 to 14% in the oxygen. Now what happens now is the machine wants to be at 14.6, and suddenly, because of that 10 to 14% more oxygen in the system after you started the generator, it now gives the oxygen, the lambda sensor, the oxygen sensor now experience a value of 15.3. This is not a very happy system now, because the engine management system is not seeing this as a good thing. What he sees is there's excess air. I'm running lean. And he's saying, but I want to be 14.6. And something has happened to this engine and I'm now running there. So the only way he can get that 15.3, that is actually the actual oxygen in the manifold because of the HHO generator, back to 14.6, is that he's got to divide something into that figure to reduce that AFR to 14.6. And the way he does it, because AFR is air mass divided by petrol fuel, he starts to increase the petrol fuel. In other words, more fuel gets injected into the combustion chamber. And he will carry on until that mixture that is sitting there starts to come down to the set point that he wants. So, just to sum it up, with the HHO generator, we were running at 14.6. We added the HHO generator. The oxygen level in the exhaust system went up to 15.3. The car management system, because of the oxygen that went up and he sees the machine is running leaner, he immediately reacts by injecting more fuel to get that value back there. And that now is exactly what you did not want to achieve. It is now counterproductive against all your attempts. Now what happens in most cases is this person will be very unhappy because he has spent 4,000 Rand to put a system in. It was running beautifully. He just wanted a little bit more fuel saving. And now he's paying for more fuel, or there's no change in the system. even if the emissions is now perfect, better emissions, car is running cleaner, he's not going to be a happy person because he can't pay back his initial cost of the HHO generator. Now, the way we do this is the same as what the chip tuners are doing. If you have a petrol machine and you want more power, the manufacturer normally restricts you on the power level. So what the chip tuners is doing, if you're running here, what they do is they tweak the sensors to let the car operate more onto here, onto the curve or at that point, while they are at the same time fooling the sensors, tweaking the sensors. So for the car in his mind and the way he experienced and reading the signals, that he's still here and he's happy to operate here. But a matter of fact, the car is actually operating here. Now the same thing we have to apply to a control system where HHO generator is fitted and where the car is not showing savings. And this is why we're using microprocessor control. Our system is not just for the operations and the control of the HHO generator. It can fulfill various functions. And because of C++ and microprocessor control, it's very easy for us to interface anything that you want to interface. So what we do is we install that microprocessor between the oxygen sensor and between the car management system. What we now do is we actually take that wideband sensor, it goes to a processor, the processors do an offset, and that offsetted value then goes back to your car management system. So the car management system never sees the real value of the oxygen. He gets an offsetted value and he will correct according to this. So for us it's very easy to do. Why I don't like a petrol machine, you can't do it to the one and leave the other one. And this is a very simple system. For us to do this on a microprocessor base, because of the voltage from 0 to 1 volt, that's already microprocessor control levels, voltage levels. And it's very easy for us to actually use that value and as a very precise value. And to actually add that offset is a matter of microseconds before we send the signal back to the engine management system. The engine management system cannot realize that he is working on an offsetted value, on a tweaked value. But just to add this, maybe I need to emphasize this. So this is very important. This is a simple machine still. Some of the machines that I came across has got 8 oxygen sensors. Now all 8 oxygen sensors must be corrected, or else you're not going to get the benefit of HHO. You're never going to get the maximum. So the one thing that we need to do is we have to tweak it. The tweaking of your oxygen sensors is not expensive, because you already paid for the control system. To add onto here is an easy interface. It's very cheap. The programming is done in the inside already. I can just open that control and actually put you another display on where you can actually adjust the offset, and I will give you a certain value of offset so you do not damage the vehicle. But the one thing that I always say as a certified engineer that specializes in control systems is that for anything that you changes in life, you have to have a backup system. Nobody knows it all, and everybody can make a mistake. But if you make a mistake, there must be something that supports you of not damaging your engine. You must not end up in a situation where you want to save 15 or 30% of your fuel, but you damage your engine and that costs you 80,000 Rand. So my duty and responsibility is to ensure that this machine operates in a safe limits. The way we do it, if we tweak this oxygen sensors, we will ask you to install a type K thermocouple onto the exhaust. Because you will understand that if we tweak the system, that a matter of fact, we're going to go into the lean zone. We know that HHO generators is producing 20 to 30 degrees less exhaust gas temperature. So we have a limit to play with. And what we do is we do not go out totally radical. What we are saying is when we tweak the say oxygen sensor, is to say we had a situation before where the oxygen sensor was running at this level. And we will tweak that signal after HHO generators has been fitted to a situation as if the HO generator was never been fitted. So we don't overcorrect or do some strange things. We just take it back to the original value, which is safe, and you still got a 20 to 30 degrees less on your exhaust gas temperature because you are using oxyhydroside gas. So to me, that EGT, what we will then do is we'll also bring that EGT temperature out to the LCD display. So while you're driving or while you're towing, you got no turbo, you got a normal aspirated machine, it should not overheat, you should not experience high exhaust gas temperatures. But if you do have a turbo on it and you got a SI machine, you will be able to read your exhaust gas temperature, which is a good thing, not a bad thing. So for us it is very easy. This is why we don't want to restrict ourselves with an electronic card that actually generates a pulse width modulation, a PWM. With microprocessor control, our world opens up because we, at least cost, can interface to the wideband and the narrowband. And we can interface all of those sensors with a simple program. We can actually then feed the correct signal and a corrected signal that is in safe limits to the ECM. Now, if you don't do this, to us it's very important. For example, if I install this, I will make sure that your EGT is not more than before after the offset has been inserted. So it is not sometimes that simple to install HHO generators. In this case, when you operate there, the moment when the generator runs, it will increase your oxygen levels in your manifold, and suddenly the machine will see, I'm now running here, so it's inducing more petrol for him to go back to here. So it's very difficult, and then it's counterproductive. You're doing the right thing, but you're not getting the value back in the forms of the fuel consumption. Now, this is in broad. I think I went through everything. We also need to understand that, I hope I got this message across, that AFR set points is never the same. It's varying all the time. It all depends on the load and what you want from that machine. Also, what is interesting is if somebody, this 0.4 values, it looks like a fixed value. It is, in a matter of fact, it's not a fixed value. It's a value, it's running like a sinus wave, but it's averaging around 0.4 volt. At the moment when the AFR increases, it goes more to the linear side. This value will just go up and it will carry on with that pulses. Now we need to discuss the diesel machine. Diesel machines, this is my friend. I like to play with diesels. Diesel is a very, very simple machine. If you treat a diesel well, if you do your maintenance, you do your oil changes, you keep it clean, you change your filters, it's no problem to you. It will give you good services. The moment when you neglect a diesel, your maintenance cost goes up, and it's always got this tendency of making sure that he gets back at you. And he will bite you the moment when you got no money in the bank. That's a diesel machine. Treat it with respect. Don't overload it. Don't go excessive gas temperatures. Don't overboost the machine, and you are a happy person. But there is two, what we call maintenance evils with a diesel machine. And I'm going to discuss this in detail. Diesel machine, they talk about a diesel cycle machine, some people, because of Rudolf Diesel invented this machine. And then this is a compressed ignition machine. Most documents, they refer back a CI because it's very easier to talk about CI than to talk about a compressed ignition machine. It's CI. Now a CI machine, in a petrol machine, we had a very short stroke, and you can appreciate this is why petrol machines has got more power. You've got a very short stroke, then you've got an explosion, the piston gets driven down, and it goes around, and it will explode. It's a very short cycle, so you can generate more power onto that stroke. A diesel machine, on the other side, is a torque machine. Because you've got a long stroke and a long compression stroke, it generates more heat because of the leverage of that stroke. Now in a diesel machine, the function is completely different. In a diesel machine, when the inlet opens and the air goes into the chamber and it closes and you start with your compression stroke, it will compress only the air into the system, and it will keep on compressing that stroke. But now you will appreciate, because it's a compression stroke, you actually will generate more heat, because what is happening with a compression, you're actually pressing the air molecules closer to each other, and they rub against each other, and they cause friction, and that causes heat. Friction causes heat, and when that piston goes nearly up, and when it reaches the top of the compression stroke, diesel fuel will be injected into the chamber, where it will be atomized as particles and suspension, and that will then ignite the mixture because the air is at a sufficient temperature. This is why with a diesel machine cannot start on its own. A diesel machine must be preheated, and that's why we've got glow plugs. And normally when you start a diesel machine, your light will come on and say this machine is now heating up. After a certain period, it will say the combustion chamber is warm enough, and you can turn your key, starter will turn, and your process will start to happen, and your combustion process carries on. If there's something wrong with the glow plugs, you will never get that engine to start, not quickly. Maybe 10-15 minutes later of cranking, it will only start. And that's a big difference between a petrol machine. So you have to understand that here we will talk about a heterogeneous environment, because there's nothing mixed inside the air mixture while it's compressing. Only when it gets to the top, the diesel fuel gets atomized when it sprays into the air. And because of the heat of the compression stroke, it will ignite. So diesel doesn't have time to mix well with your air particles and to form a proper combustion mixture. It is stuck more or less in the middle as it's getting sprayed in. That's why we use the term heterogeneous. Well, you will also appreciate in a petrol machine, for example, right in the beginning of the stroke, your mixture, your fuel gets injected into the chamber and then compressed. So it's got a long time, and petrol is very volatile, so it will start to move around, and it will actually circulate around the molecules, so you will have a more uniform distributed fuel inside your air while it's compressed. And when your gasoline machine gets to the top, a spark will ignite, and because there's a good mixture of fuel, it is perfect and it will burn. But with diesel machines, you're losing a lot of efficiency on the combustion process. Because it's in the middle, you don't use the full chamber, it's not mixed properly, it's all kinds of funny things. The moment when you start adding HHO generators onto your machine and it generates oxyhydroxide gas, because hydrogen is also a fuel and it's additive, it is distributed right through that molecules. And the moment when a compression stroke is finished on the diesel machine, on the CI machine, and it gets to the top and the fuel gets sprayed in, the diesel fuel gets sprayed in, it will ignite, and it will also ignite the hydrogen. Now we need to understand, and a lot of people has asked me questions with this before. One of the questions that was asked to me during the compression stroke of a diesel, if I got a 20:1 compression ratio machine, will the hydrogen not ignite and then make a knock on the engine pre-detonation? Now, if you look at hydrogen auto-ignite 500 degrees, higher than 500 degrees. It's around 540 degrees Celsius. If you talk about a diesel machine, the fume ignites about 210 degrees, diesel fume. So because of that 500 degrees on auto ignition temperature on your hydrogen, it will not actually generate enough heat to ignite the hydrogen. It's the same with a turbo. A turbo compresses to about 2 bar. So if you allow your HHO generator to be inserted here, when your HHO generator and a gas mixer get to the turbo, and a turbo normally compresses about 2 bar, maximum 2.5. When it compresses here, it's not enough heat to actually get that mixer to explode here. It will, in your combustion chamber, no problem. Don't make a mistake. Hydrogen is explosive. A small spark, a small problem can ignite it. That's why you don't want, in your combustion chamber, you don't want carbon inside your combustion chamber, and we will return to this later. Now, your primary loop is a closed, it's actually not a closed loop system. I made an error there. It's actually more of an open loop system. It measures the air. Guys, this is a correction. It's an open loop system. It measures the air. It determines how much air is going into the system with your mass airflow sensor here. And on your mass airflow sensor, then it will take into account a lot of other sensors. For example, what is the temperature of your fuel? What is your pressure of your fuel? It will take in what is the air temperature, what RPM is it running at, is it zero load, is it full load, is it half load? It will take in all of those accounts with this mass airflow sensor, and it will then what we call mapping. It will map a certain setting to your injector, and it will say, for all of these parameters, I need to inject fuel into your system at this quantity. And a diesel machine is a lean machine because it's working with air, it's compressing air, and it's only at the final stroke where you inject your fuel. It's a lean machine. And when we talk about a lean machine, we talk a normal, optimal. This is the practice. This is on the in the paperwork world that we're living in. At 14.5, that is the optimal AFR, and it has been shown here. But what we found is that the best consumption that we can get on a diesel is around 18.2. What is also interesting, the maximum power is 12 to 30. And again, it fits our curve. This is your power side, that's your reach side, and that's your lean side. But what is interesting here is you don't want to run at 14.5. At 14.5, if you run for a long period on 14.5, a matter of fact, in practical, you start seeing smoke. So your motor manufacturer, with a petrol machine, will tend to run more on this side, but on a diesel machine, they will more run on the lean side. On the lean side, if the machine is decelerating, it can go up to a ratio on the AFR scale from 100 to 1 easily, and it can go down to 6 to 1. If you're an off-road person and you are running up a sand hill, you need maximum RPM. You will probably run that sand hill probably in third high, and you will probably have your foot flat on the floor. You want maximum power and maximum fuel in that machine. And this is normally when it's running totally rich, then you will see the black smoke coming out of the diesel. That is all unburned fuel and rich. If you go this way again, This is when you start getting black smoke, unburned particles. So diesel tend to sit more on this side here. Now to discuss the two maintenance evils, and just to show you how easy it is to get a reliable engine. A diesel machine is not built for a year or two ownership. A diesel machine is a long-term machine. It's a machine that is built of heavy components, stronger components. It is components that it can last for a longer time than a petrol machine. A diesel machine can last 500,000 to 1,000,000 kilometers easily. Now, we need to discuss this a little bit more. And I just want to come to the two maintenance evils. That's the two things that will determine how long your engine is going to live, or how soon it's going to die. We've got an air inlet filter. If you're in a dusty area or anything, it gets filtered out there. It goes past a mass airflow sensor. It goes to the turbo inlet here. The turbo compresses it, and because compression is involved again, your inlet temperature air will be lower than your outlet temperature. Because of that compression, the temperature will rise. Because you've got a temperature rise, your air will be less dense. So you've got to get rid of that heat. So you make use of an intercooler. You push it in the intercooler. As you drive, the air that is rushing through your intercooler actually remove some of that heat, and theoretically it can go down what we call approach temperatures of the same as ambient temperature. So if you have an ambient temperature of 25 degrees, it cannot cool lower than 25 degrees. So that cooled air now is going into a manifold. It then flows into the combustion chamber. Your machine look at that system there. It determines how much air is flowing. It knows exactly what to inject. It injects the quantity of fuel that is needed for that mass air that has been injected. And it then combusts it. It then goes into the exhaust, and that goes out to the atmosphere. Now this system works perfect on paper. So from cradle to grave in the environmental concept, this is the more or less the processes that is important that is happening. And the one thing that I also need to discuss, from year 2000, all the diesel vehicles are fitted with the EGR because of emission standards. And what the purpose of this was is to reduce NOx and to reduce exhaust gas temperatures. Because as you remember, if you reduce your exhaust gas temperatures, your combustion temperature, then you will get less NOx. And NOx is one of the things that you do not want in the environment. So theoretically, what the concept was that you take some of the exhaust gases, you push it back in the EGR, and the EGR will push it back in the manifold. From the manifold, it will go into the combustion chamber, where it gets reburned. So this is the CO2 gases and things like this. You can see it as like dead gas. That's not active gas, it's a dead gas that's going in here. So it reduces your mass airflow sensor, because you're recirculating, you're bleeding back certain of the exhaust gases back into the system. And because of that bleeding back effect, you now reduces your mass airflow that's going inside your machine, and your mass air sensor will actually pick that up. It will then reduce your diesel injected in your machine. So you will get a lower EDG, exhaust gas temperature, and it will then be reburned and it will be exhausted again. In practice, this is one hell of a nightmare, because what you will find is on diesels, most of these EGR ports, it's been blocked off here somewhere. It's no longer function. So what we got now is a diesel that has only got that process from cradle to grave, and all emissions is now just going untreated to the atmosphere. And then that person cannot look a tree in the eyes. He cannot hug the trees. He's got to look the other way every time when he walks past a tree. So this is not what you want. You don't want to be embarrassed by a tree, so at least keep that open. But you can't keep it open because what is happening, all the soot is going through the EGR, going back in the manifold, and that soot is building up your manifold, restricting your air that is now going into the engine. And that is restricting your power, it's affecting your fuel economy, and you now have a very sluggish diesel. But there's now also another little culprit in this whole scenario that you will understand in the combustion chamber. When the combustion process has taken place, inside the combustion chamber you got a piston. That piston's got metal seal ring in, and that metal seal ring is not 100% ring. Some of the gases will actually escape from that chamber and end up, because of the pressure, especially on diesel, will end up in an engine crankcase. Now every 5 milliseconds you got a combustion process. So every 5 milliseconds gases are being added to the engine crankcase. Now this is not very healthy. So if you do not vent that gases, what will happen? It will start to blow out the seals on your system. And now you suddenly got a lot of oil leaks onto your system. That's why there's a valve, PCV valve has been fitted, and that PC valve will actually allow that gas to escape, and it will end up into the inlet of the turbo. And that oil then will carry on and will burn. But that's not a good news. This is very bad news. Because what happens is, this is hot. You got the oil mist as well inside that gases that is inside the air and is moving along here, then gets compressed by a turbo where heat is generated, and it is now well inside that air because it's now like super saturated with that oil inside the air. It then moves into the intercooler where it gets cooled, and guess what? Because there's a temperature difference between here and there, your oil starts to settle out into your intercooler. The moment when that happens, you get hot gas there, you get hot gas there. It's no longer an intercooler, it's just an inter. So what happens is your temperature that is there just stay the same temperature, it's less dense. So you're actually reducing your air intake that you get into the machine. And this mass airflow sensor will then tweak your fuel to inject less. What is also very scary of this horror movie is that this is a very, very gradual process. It is so slow that you never realize that there's something wrong with your diesel. So now what happens is this oil goes into your manifold. Now you got the two worst enemies that you can find. You get an oil entry point and you got a soot entry points. And these two bad enemies are good friends. This is wet and this is dry because it comes from the combustion process. So this wetness here combines with the soot and it forms a black paste inside your manifold where it stays forever. Now this process never stops. You keep on adding soot, you keep on adding oil. Keep on adding soot, keep on adding. Now a lot of things start to happen. Your exhaust gas temperatures are starting to rise. Your car is sluggish. It doesn't want to accelerate because your manifold is now getting blocked day by day by day. And I will show photos at the end of this video of what can happen to your vehicle. And this process happens with every diesel vehicle. Now, you pay for this out of your own pocket. You're paying for reduced fuel economy because the engine is no longer operating in the parameters that it's designed for. Now, what the good news is, it is so simple to resolve this and to get an engine to operate at the best parameters that you can find. And what is easy to understand, that we only have to install a separator here. When you install a separator here, it will actually remove that oil vapor. I just want to go quickly here. So if you install an oil separator here, this one here will disappear. Because what is happening now, this oil separator is got a partition in between with a foam inside. I bought my one for 2,000 and it's working like a dream. I got zero oil into the system from here on. Zero oil. So all that oil must go through that filter. It then gets condenses. It stays in this separator, and you can actually drain it. The effect that you got now an engine that's working. Your turbo stays clean. Your intercooler is staying clean. You got the power because now this high temperature that is here gets reduced to a lower temperature, and you no longer have a friend for your soot entrance point because you're moving the oil. So now you will see that some of that soot now will actually end up in the combustion chamber. It will go past, which is better. But you're still sitting with this little devil here. So what we now need to do is very easy. If I can get that. What you need to do is to get rid of this. So what you do is you put here HHO generator. At this point, and you supply it with oxyhydroxide gas. Now what the devil does a HHO do to the system? Very easy. It can go up to 77%. Less fuel. Apologize. That is very difficult to use that. It stands for less. It doesn't look like it, but it is. So what you're doing is, with a HHO generator and with a separator there, you now got rid of your oil. You got rid of your oil, your soot entrance point. Your EGR is no longer blocked because that exhaust gases can actually go through the system, and it can function as designed. Because you got 77% less gas. And you must also understand, or one thing that's very important here. If you don't put this in, when you get home, not even when you get it home, this process of blocking is stopping. The moment when you don't have this and that onto your system, as you switch off your car and you go home to watch the TV or have a beer or talk to the wife, the oil that is saturated in your manifold will start to seep down here into your EGR. Because your EGR, you will find that your EGR is normally at a lower level in the car than the manifold. So while you're sitting and watching the TV and having a beer, this car is siphoning oil down here in this tube. If there's not enough oil, it will just stop. The next morning you start your car, all of those soot will now start to combine here. And now you will start plugging this area here. Tonight you get home again, you switch off your car, you go and watch the TV, there's enough oil here again, and now, because there's oil here, it will go faster down here until it reaches the dry area, and it will start siphoning down, and this process will carry on until it reaches the EGR. It will actually go into the EGR, and because it's a lower part of your engine, it will accumulate on the top of the EGR. The moment when you use this machine, this EGR will kick in the moment when the machine is hot at operating temperature. EGR does not function when the machine is cold and you're busy starting and it's busy heating up, because exhaust gas emissions depends on a lean condition. It depends on high combustion temperatures. But you won't have a high combustion temperatures while you're heating up the vehicle. So this will only kick in when the water temperature is at operating temperature. And then it will start to adjust, and all depends on the load. If you're full load, zero load, whatever, your engine management system will then control this. But then your oil is now inside here, so your suit will now start to block here, block there, block there, block there. And this process will just carry on until you cannot drive it anymore. So you now have a diesel vehicle that's not a very happy diesel vehicle. And the trick here is, the only thing that you had to do to get the tick mark of what we call your maintenance evils. There's two maintenance evils: your oil entry point and your suit entrance point. That, unfortunately, is what you have to do. You cannot get rid of this. This is a part of a diesel. And for any diesel that you got, if you want a reliable diesel with the least maintenance cost, there is two parameters that you got to control. You must make sure that you never overboost on your turbo, and you must make sure that your exhaust gas temperatures, your EGT, always stays in control. To get EGT in control, you've got to make sure that your soot devil and your oil devil disappears very quickly. You don't want those two into your machine that costs 400,000 rand. You don't want it. With the emission system, unfortunately, before this system here, this went into the atmosphere and poisoned the planet. We moved it from there into here, and it's now stuck here. That's the only thing that changed. Because the reason why is, we never changed the combustion process to get 77% less soot. But if you fit a HHO generator, you're not going to work with the symptoms of the problem, but with the solution, with the combustion process itself. And by adding HHO, you're getting between 40 and 80% less soot in here, which is perfect. So then the concept will work. But you got to do HHO and you got to do this. There is no choice. What is interesting in diesel vehicle as well, the two critical parameters, your exhaust gas temperature and your turbo, will determine the life or the death of your machine. If you overboost and you got high exhaust gas temperature, goodbye diesel. That's how simple it is. A diesel machine, because it's a lean machine, you got excessive exhaust gas temperatures. When you work this machine 550, 570, 600 degrees is nothing strange. If you really abuse this machine, you can reach temperatures of 850 degrees and anything above 700 degrees. You can reach a temperature where the diesel destructs itself, where your piston melts down. So to me, it does not make sense. For example, and this is why I had a request, because those two parameters will determine your lifespan of your diesel. And this is for the user. If he wants to, he can put in his HHO generator, put this in, get the benefit. From the saving that he generates, he can now put in 2 gauges without putting in 2 dial gauges into his car and modifying the car to get all of those stuff through. We can add it very quickly because we interface with the exhaust sensor and we interface with the manifold absolute pressure. We can bring that out to the LCD display at least cost. And I think this is why people will understand why I'm using microprocessor control. Because my control panel itself, my little small panel, is inside the vehicle. So from the exhaust I go to there, and my turbo, I take that signal also to the control panel in the inside of the panel, that is inside the engine, and I display it on an LCD display. Very easy, very effective. Now what is interesting to note here, that people today are still blocking EGR. We now got to look at the emission standard. In January 2000, it was already saying that PM for a diesel machine should be 0.05 gram per kilometer. They work out the kilometer based on highway, urban, off-road, all these kinds of funny things to get that value. And there's a whole formula that they use. But today is 2021 and we're still in a situation that we're still blocking off that EGR. So that emission standard was not achievable. That's what I'm saying. Because of that suit challenge that they got. But now we got more intelligent and we now went to Euro 6 standard. Euro 6 standard, if you look what they're going to add onto now from B, it's going to flow into a DPM. That is your diesel particulate matter filter that is sitting there. And all that soot is now going to end up here. So we had a situation like this now. Before that soot ended up in the environment. When we changed the standard, the soot ended up in the EGR and the manifold. So now we have another scenario, the third scenario, where all that soot will end up in here. Now I can see block filters. I can see it coming. I can see a replacement of this. I can see all kinds of chemicals being used to clean this. That black stuff will just end up in your garbage bin and probably end up in the soil. So we're still sitting with this solution. Even if you fit this, it makes sense on a piece of paper. In reality, this ends up in the soil. Because somebody will clean this filter, wash it away, it will get into the water or in the soil. So your environmental problem is still there, even if your exhaust gas temperature is complying. This footprint here, your impacts and aspects of that soot will still affect negatively the environment. So what I'm saying is, instead of trying to add onto here all these funny things that requires maintenance and things like this, let's go back with HHO generator and fit this. So even if you've got a vehicle that is designed like this and it's a new standard today and you're very happy with your vehicle, make sure that you don't overload the systems here so you don't have to replace these components. And to make sure you have to reduce this soot here. So when you reduce 77% of your soot, you only got like a 20%, 23% of soot that you got to deal with. And it makes sense that your problems and your maintenance costs will be 77% less. We got here a selective catalytic reaction, and guys, they are proposing that we use AdBlue or DEF, diesel exhaust fluid, into here, and it will scrub off your COs and CO2s and sulfur gas and all of these kinds of funny things will be scrubbed off here, and we're going to have a wonderful environment. If I look in the first standard, people blocking off this EGR, which is illegal, you will not pass emission test when that's been done. They will take your vehicle away. And you now have to apply from today onwards with this system here, where you need 8 more probes just for the control of this. It is quite difficult. Now a lot of guys are saying to me, and I found myself in this argument, and I refuse to be drawn into an argument like this. Now, what they say, if this is so wonderful that it removes the oil and it's got a positive effect, and they can understand that oil in the intercooler doesn't work. Their question is always to me is, why did the motor manufacturer not install that? Now I can't answer that question. You're asking a question to the wrong person. I'm just the person using it, and I'm experiencing the effect of this. And at the same time, they will ask, but why, if this is so good at reducing the soot, why is that not been done? I can't tell you. All I can tell you is I install HHO generator to increase the life of my diesel. And I love my diesel enough to make sure that it doesn't poison the environment, it doesn't create excessive greenhouse effects. I make sure that I'm operating at 77% less soot. So if I have to clean the system, I don't contaminate the soil. The one thing that I can say is, your motor manufacturer doesn't make money when he sells the vehicle to you. When you put that brand new keys in your hand, very little profit has been made. After 2,000, 2,400, 2,500 different components has been assembled in a motor car, very little profit has been made. What they do make profit on, by changing your turbo, changing your intercooler, changing your EGR that is faulty because of all the blocked carbon. All of these funny things. And now we got even more. Changing the DPM, changing the SCR. Guys, I want you to go and look at the cost of changing a DPM and the cost of changing an SCR. This can cost up to 1/3 of your vehicle. And you cannot operate without them. This is why they got 8 sensors here, monitoring every aspect. And you will not comply with emission testing if you're fiddled with this or you remove that. So, this is basically that, guys. So, the choice is yours. I'm not here to convince you. All I can tell you is that we got the control system, and that's what we're going to specialize in the beginning, is in the control system. I really want to push this forward. I believe that every diesel machine in this world must have an HHO generator fitted and must have that separator. We don't supply the separator, but I know people that can, various people. I've got 6 or 7 suppliers. And I'm very happy with that. You want it to be fitted. We are now busy fitting this. My vehicle is 400,000 kilometers on the clock, and I bet you my vehicle is available to you. You can come and do a compression test anytime on my vehicle, and surprising enough, the compressions is not in spec. It's like the same as the day when it was pushed off the shop floor. There is no changes in my compression, and I believe it's got to do there, and that was the key. Because I have never exceeded exhaust gas temperatures. I don't push 800 degrees. I will just take the load off the moment I see the EGG is coming up. What I am saying is, be careful the way you implement it. I am available all the time. I'm not going to charge you money if you ask me a question or you got a request. And it's for you to decide. But this must be fitted. And what I want to tell you is, please install our control system on this. Because with a pulse width modulation is the only way that you can control a cell, a HHO cell, safely. Microprocessor base of C++ with an end user screen. You've got all the parameters. And if you want to see exhaust gas temperature, it's a type K thermocouple that we weld. It's a little small socket that we weld the closest to your manifold. We install it, you can read up to 980 degrees. And trust me, when you see 980 degrees, kiss the machine goodbye. But at least when you tow or you go up a hill, at the moment, your car manufacturers do not show you the exhaust gas temperature. But this is a very critical parameter. And if you tow a heavy caravan up a hill, foot flat on the floor, you don't even realize that you're reaching here 720, 750 degrees. You don't realize what damage you're doing here, then there, then here, and then the rest of the engine to follow. So if you want to interface this, very easy. For us, it's very easy. If you've got any challenges with yourself, I got no preferred supplier on the HHO generator. You can buy it from any place, but because you got our system, you can control it safely, no problem. I hope somebody learned something more about this, and I hope somebody sees what is coming. And all I can say is, guys, diesel machine. I've used this machine. Today I'm 61 years old. I've used a diesel machine all of my life. It never allowed me to stand in the veld. I go off-road in strange places. But because I treat the machine well, and I treat it, and I make sure it doesn't make soot, I make sure there's no oil, this machine will take me anywhere and bring me back to any place. But I tell you now, when you run off-road situations and you haven't got this and you haven't got that, it's a matter of time before you're picking up challenges. And again, guys, I don't know it all. This is the way I understand it. I apologize for that. Closed loop, it's actually open loop. Again, please ask questions. I'm a very curious character. When a person asks me questions, I learn. And that's why I like questions. I don't know it all. Nobody knows it all. I know people that is 80 years old that still learns. We all learn until the day when we say goodbye. But by asking questions, we will understand the concepts better. And we will know how to achieve it better. And that creates a win-win situation. So please do not hesitate to ask questions. And if you want to, please subscribe, because I will add some more videos later on the HHO generators and things like this. And I will soon start to publish my own results. I'm going to show you my logbook and what we achieve and the things that we have done, and to see what happens in the future. Guys, I hope you learned something. Please ask questions. Thanks a lot.